If you've taken AP Calculus or any college level calculus class, you may have seen statements similar to this. Let f, be a function that's continuous on the closed interval and differentiable on an open interval. And you might be wondering, why can't they just say let f be continuous and differentiable on the closed interval? Why are we not able to be differentiable on a closed interval? And the short answer is it kind of just depends on what your definition of differentiability and continuity, for that matter, what those definitions are. But let me give you the longer explanation. And this relies on the idea of part of the definition of differentiability. So here is one portion, and I'll just write it down and then explain it. Okay, so what this is saying is that the limit of f prime, so the limit of the derivative, approaching from the left and from the right have to be equal to each other. This is just a portion of the definition of differentiability. Then you need continuity and then some other things, but this is a big portion of it, okay? And the thing is whenever you have, let me just draw an example. Let's say we have some function and it's defined on this interval, right? So that interval, and then we have closed off points there, okay? And so if we are trying, so obviously, this function seems to be differentiable across its entire domain. It doesn't seem to have any problems or anything. It's continuous, it's pretty smooth, so it's fine, right? So we could, just apply this in addition to our other parts of the definition and find the derivative at anywhere on its domain. What about the endpoints, though? If we're trying to apply this idea, let's say to this left endpoint, well, we can find this limit. That's fine, because we're just trying to say, like, okay, we are approaching from the right. Okay, we can find that limit. But what about approaching from the left? Our domain doesn't exist there. Like, our domain doesn't go past this endpoint. Our function isn't even defined over here. So there is no left. We actually cannot find this. This is not something we can find. So really, what's happening is, like, if we claim that we can have a derivative at this endpoint and also this endpoint, right? Then we have to say, well, we don't have to satisfy the idea of a two-sided limit, right? We only have to, this is the only limit that has to exist for the left, and then this one would be the only one that would have to exist for the right. And so we're basically like excluding this criterion from the endpoints. And so basically then our definition of differentiability would be, you have the whole definition for every part on the endpoint, but for every part on the interval, but at the endpoints, this doesn't have to be satisfied. And so that kind of gets rid of a whole, chunk of your definition. And so it kind of breaks down. And so for that reason, they actually just say, okay, no, you cannot be differentiable at the endpoints, because we do want this criterion to be satisfied everywhere. And if there is no left, or here if there is no right, then this isn't going to work. So that explains the differentiability part. What about continuity? Because remember, continuity basically says the same thing, except I'm kind of getting rid of this whole thing, except it'll say as x approaches c of just f of x, not f prime. And then the same thing here, it'll just say f of x. And so basically it's the same sort of thing, because the problem here with continuity is that, again, like for this left endpoint, we can find this. This is pretty easy to find. Again, we're just approaching from the right. But approaching from the left, well, there is no left. So what's going on here? It's the same issue that we had with differentiability. The difference is that AP, and maybe your college class, they decided that the continuity definition will have that exception for the endpoints, where this doesn't actually have to be satisfied at the endpoints, but it does for the differentiability definition, whenever you have f prime there. So it's kind of an inconsistent thing. I don't exactly know why they do it, why they couldn't just be consistent, but that's just how it is. Really, it's just up to your definition. Do you want this this little criterion to be satisfied everywhere, or are you willing to sacrifice it to include your endpoints? So that's pretty much the concept of that. So I hope you enjoyed. I hope this made everything clear. And yeah, thank you for watching.